The order came down with shocking speed, echoing through command centers from Vandenberg to Cape Canaveral. Launch window moved. This wasn't a drill, but a desperate last-minute maneuver by the Space Force. The unseen threat? A celestial phantom, Comet 3I Atlas, hurtling towards our orbital neighborhood.
It's the third object discovered from outside the solar system that is heading our way.
The potential for disaster was immense, a cascade of events that could cripple global communication and navigation for years. What triggered this unprecedented panic? You see, the raw numbers behind this comet's close shave are truly jaw-dropping, making this a story about more than just a changed schedule. This was about safeguarding our entire modern world from a silent, fast-approaching danger. Why the clock stopped? You see, the protocols for space launches are incredibly strict, measured down to the second, involving years of planning, billions of dollars, and the combined effort of thousands of brilliant minds. To deviate from this plan so suddenly suggested something truly extraordinary, even alarming. The thing nobody tells you is that a launch window isn't just a suggestion, it's a precise calculation based on orbital mechanics, target destinations, and crucially, avoiding any known hazards in space. The abrupt change wasn't a choice, it was a forced reaction. Comet 3I Atlas, discovered just a few months prior, was initially a distant curiosity. Astronomers had been tracking its path, but its interstellar nature meant its behavior was less predictable than comets born in our own Oort cloud. These objects travel at incredible speeds, often tens of thousands of miles per hour, faster than anything we're used to in our own solar system. To put it mildly, this comet was a speed demon, screaming through the void. Early estimates put its closest approach at a safe distance, hundreds of millions of miles away. But not all things are what they seem in the vastness of space. What truly sent the Space Force into overdrive was a sudden refinement in the comet's trajectory. New data gathered by a network of powerful telescopes and deep space radar arrays revealed a disturbing update. The comet's path, originally thought to be safely clear, now presented a concerning overlap with Earth's orbital plane. And worse, it was projected to pass through a specific orbital corridor that was not only heavily trafficked by satellites, but also intersected with the planned launch path. The initial safe distance had shrunk from millions of miles to a mere few 100,000 miles, a hair-raising proximity in cosmic terms. Many people are crazy about how precise our space tracking is, but even with our best tools, these objects can surprise us. To give you a sense of the scale, Earth's average distance from the Moon is about 238,900 miles. Comet 3I Atlas was now projected to pass within roughly 300,000 miles of Earth, a distance that, while still far, is uncomfortably close for an object traveling at such immense velocities. Its speed was estimated to be around 125,000 miles per hour, nearly 2,000 miles per minute. Imagine something the size of several football fields, moving at that unbelievable speed and coming within a stone's throw of our planet's busy orbital neighborhood. The kinetic energy alone of such an object would be beyond devastating if it were to collide with anything. The decision to move the launch window was made at the highest levels, a frantic conference call involving generals, NASA's administrators, and orbital mechanics experts. The risk wasn't just to the rocket and its expensive payload, but to the entire launch infrastructure. A mid-air collision with even a small fragment of the comet or debris kicked up by its passage could be catastrophic. The most shocking fact is that even a piece of debris the size of a paint chip can cause severe damage to a spacecraft at orbital velocities. This isn't just about direct impact, it's about the cloud of tiny particles that often accompany comets, like a cosmic dust storm. The clock was reset. Teams worked around the clock, fueled by adrenaline and black coffee, to adjust every single parameter. New flight paths had to be calculated, new launch conditions verified, and every piece of ground support equipment recalibrated. This wasn't just moving a flight, it was practically redesigning a mission in real time under immense pressure. The engineers and scientists involved knew the weight of their decisions. One wrong calculation, one missed piece of data could spell disaster not just for a single mission, but potentially for many operational satellites orbiting Earth, and you can see this everywhere when you consider how interconnected our world has become. The panic wasn't just confined to mission control. News of the abrupt change, though initially vague, started to leak, fueling speculation and worry among the public. Was something truly dangerous heading our way? What wasn't being told? The official statements were reassuring but couldn't fully quell the underlying tension. People started wondering about the dozens of critical satellites that provide everything from GPS navigation to weather forecasting and global communications. A hit to just one of these could have far-reaching effects on daily life. The world held its breath as Space Force navigated this cosmic crisis, revealing a disturbing truth about our vulnerability in space. The unseen dangers of space are far more complex than a single rogue comet. Whispers of near misses. The near collision with Comet 3I Atlas brought to light a truth many in the space community have whispered about for years. Our orbital space is becoming incredibly crowded, a cosmic traffic jam waiting for a major incident. What many overlooked is that this isn't just about big rockets and satellites, it's about the growing amount of space junk. Everything from defunct satellites to discarded booster stages and tiny shards from past collisions. You see, an event like the sudden arrival of an interstellar comet only adds to this already perilous environment. Consider the sheer scale of objects we have in orbit. There are currently thousands of active satellites performing vital functions for science, defense, and our everyday lives. But the thing nobody tells you is that there are also hundreds of thousands of pieces of tracked space debris, some as small as a marble, circling Earth at incredible speeds, often exceeding 17,500 miles per hour. At such velocities, even a tiny object carries the kinetic energy of a bowling ball, hitting you at over 100 miles per hour. That's enough to punch a significant hole through a spacecraft or even a space station module. The challenge with Comet 3I Atlas was magnified by its unexpected nature. Unlike most asteroids and comets that stay within our solar system, which we track with increasing accuracy over many years, an interstellar object appears seemingly out of nowhere. It's like trying to predict the path of a random bullet fired from a distant, unknown gun. This comet wasn't following the familiar orbital dance of our planetary neighborhood. It was a tourist passing through, and its interaction with our sun's gravity provided the crucial but very late data points that showed its true alarming trajectory. To put it mildly, the refined trajectory revealed a keyhole passage, a narrow corridor in space that, if passed through, would significantly alter its course, bringing it even closer to Earth or even our moon. While not a direct impact threat, the gravitational pull and the potential for a dust cloud to expand into our orbital lanes were very real concerns. A comet, unlike an asteroid, is not just a solid rock. It's a mix of ice, dust, and rock, and as it gets closer to the sun, it sheds material, creating a vast, often unpredictable coma and tail. Imagine flying through a cloud of icy sandpaper at breakneck speeds. Many people are crazy about the idea of asteroid defense, but a fast-moving interstellar comet presents a different kind of challenge. We had minimal lead time. It wasn't about nudging it off course, it was about getting out of its way. The Space Force, in conjunction with NASA and other global space agencies, had to pool every resource, every sensor, and every bit of computing power to get the most accurate picture of 3I Atlas's path. The coordination required was monumental, a testament to international cooperation in the face of a cosmic threat. The most shocking fact is that even after the launch window was moved, residual anxiety lingered. What if the comet's outgassing? The release of gas and dust from its icy surface created a larger, more dispersed cloud of material than predicted. What if a large, previously unseen chunk broke off? These what-if scenarios, while perhaps remote, are the stuff of nightmares for mission controllers. The gamble was that the new launch window would allow the rocket to clear the danger zone before the comet's primary passage, and certainly before any significant debris field could expand to dangerous levels. The incident forced a reevaluation of our planetary defense systems. While much focus has been on Earth-bound asteroids, the arrival of 3I Atlas, following on the heels of other interstellar objects like Oumuamua and Borisov, highlighted a new category of threat: fast-moving, unpredictable visitors from beyond our solar system. We need new ways to detect these objects earlier, to track them with greater precision, and to understand their composition and behavior more rapidly. It's a race against cosmic unknowns. This wasn't just about saving one launch, it was a wake-up call about the increasing vulnerabilities of our space-based infrastructure. The true extent of our reliance on space might surprise you. Our cosmic protectors. The Space Force's swift action regarding Comet 3I Atlas wasn't just a domestic affair. It sent ripples of concern and urgent collaboration across the globe. What many overlooked is that space is a shared domain, and a threat to one nation's satellites is, in many ways, a threat to all. This incident became a stark reminder of our interconnectedness, not just on Earth, but in our shared orbital environment. Imagine a world without GPS, without accurate weather forecasts, without global satellite communication for banking or emergency services. The thing nobody tells you is that a cascade of satellite failures due to space debris, potentially triggered by a comet's passage, could plunge parts of the world into an informational dark age. This isn't sensationalism, it's a very real concern for orbital scientists, often referred to as the Kessler syndrome, where collisions generate more debris, leading to even more collisions, creating an impassable barrier around Earth. The 3I Atlas situation, to put it mildly, felt like a brush with the edge of that nightmare scenario. Many people are crazy about the idea of space tourism, and it's certainly a captivating future. But this incident highlighted the need for robust space traffic management, not just for government and military assets, but for the rapidly growing commercial space sector. With more and more private companies launching satellites for broadband imagery and other services, the airspace above us is getting incredibly busy. The lack of a universally enforced rules of the road for space is becoming a significant vulnerability, and you can see this everywhere with the increasing number of close approaches between satellites. The response to 3I Atlas was a testament to the dedication of orbital analysts who worked tirelessly, often out of public view, to track every piece of space junk, every known asteroid, and every potentially hazardous comet. These unsung heroes crunch mind-boggling amounts of data using supercomputers to predict trajectories with astonishing accuracy. The most shocking fact is that their work often goes unnoticed until a crisis, like this one, forces it into the spotlight. The information gathered from tracking 3I Atlas, while causing immediate alarm, also provided invaluable data for understanding interstellar objects. These cosmic wanderers hold clues about the formation of other star systems, offering a rare glimpse into worlds beyond our own. The panic, therefore, was tempered by scientific curiosity. How common are these objects? What are they made of? Do they carry unique materials or even microscopic life from distant stellar nurseries? These questions are driving new missions and new telescopic observations, pushing the boundaries of human knowledge. But not all things are what they seem. While the immediate danger of 3I Atlas passing was averted, the incident sparked a deeper conversation about future threats. What if the next interstellar object is bigger, faster, and on a collision course? What if we detect it too late to move a launch, or worse, too late to protect our planet? This isn't about fear-mongering, it's about preparation. Organizations like NASA's Planetary Defense Coordination Office, along with international partners, are actively developing strategies and technologies to detect, track, and potentially mitigate such threats. The creation of the Space Force itself, which many people are crazy about for its distinct role, takes on new meaning in light of such events. Its mandate isn't just about military operations, it's about ensuring the security and accessibility of space for all beneficial uses. This includes protecting assets from both terrestrial and extraterrestrial threats. The sudden move of a launch window wasn't just about avoiding a collision, it was a visible demonstration of this commitment, a clear signal that the safety of our orbital domain is a top priority. This event forces us to ask, are we truly ready for the next unknown visitor from the deep cosmos? The biggest questions about space are often found in its most unexpected moments. The drama surrounding the Space Force's abrupt launch window change as Comet 3 I-Atlas passed might seem like a singular, intense event. But in reality, it was the culmination of countless hours of unseen effort and a testament to human ingenuity under pressure. The universe is full of surprises, some beautiful, some truly terrifying. The tale of 3I Atlas passing near Earth raises a crucial question. Are we truly ready for the next unknown from beyond? Like this video, subscribe for more incredible space stories, and tell us your thoughts below.